As we continue, it's my pleasure to introduce Sipke Skorstra, creator and maintainer of Elsa Workflows. Discover how the new Orchard Core.Elsa Workflows module brings the power of Elsa Workflows to Orchard Core. In this session, we will explore how to automate and extend your CMS using workflows that can respond to content events, send and receive HTTP requests, query the database, and more. We will also cover how to create custom activities to fully unlock the potential of this seamless integration.
Hi everyone, my name is Sipke. I'm a software developer from the Netherlands, and I've been a Orchard Core contributor, or actually Orchard contributor since 2011. I've done a lot of work with the project. It essentially bootstrapped my career as a consultant. And I've been working on it roughly through 2016. That year I worked on a big new project, which originally started with Orchard Core, but for certain reasons, technical reasons, we had to change it to use a different platform. But one of the key features that was missing was the workflows module. And so a year later, I started a little project myself based on the Orchard module, or the workflows module within Orchard. And yeah, in this session, we're going to talk a little bit about that. I'm going to explain in more detail what is Elsa and how it can fit into Orchard. So this is the agenda. So we're going to look into Elsa workflows. We're going to see how it integrates. We're also going to see how we can extend it with custom activities. So, in a nutshell, what is Elsa? It's a set of NuGet packages. It's open source, and it allows you to build your own workflow engine, very much the way you would do it with Orchard, where you enable the workflow module, and presto, you will have a workflow engine. In fact, Elsa is an offshoot of the Orchard Core workflow module. So we can see here a little sort of a timeline where we have the Orchard Workflows module. I took the source code. Back then we didn't have ChatGPT. We had Sebastian's implementation of a workflow module. So I took that, learned a lot from that. And then Elsa was basically stripped from all dependencies of Orchard, and then it was reusable in your own .NET application. And that caused that package to evolve in its own direction. So it received many new features. It was hardened also for enterprise use. And so we evolved Elsa all the way from version 1 to the current version, version 3. And I've always been wanting to integrate Elsa back into Orchard. Elsa is embeddable in any .NET application. Orchard Core being a .NET application, it makes sense. So because of this origin, they are, in many ways, they are very similar. They both support short and long-running workflows. Obviously, it's an extensible system. There's a web-based designer, which is a key feature of the workflow engine. It's based on .NET, and they are both awesome still to this day. Of course, there are differences. Elsa is embeddable in any .NET application, which is also the focus for this project. But it also, as of Elsa 3, takes completely different architecture in terms of the activity design. For one, it's composable, which is heavily inspired on Windows Workflow Foundation. What that means is that you can have an activity referencing another activity as a property that it can then schedule under certain circumstances, which enables very advanced use cases. For example, the flowchart activity in Orchard and in Elsa 1 and 2, that's basically the engine. In Elsa 3, the flowchart logic, it's just an activity, so it's been abstracted away. which also allows us to do different kinds of state machine itself could be an activity which we don't have today, but that is a roadmap item. We have a sequence activity for simple step-by-step diagrams if you want to work with that. It also supports code-first workflows, so you can design workflows using the designer that is then stored as JSON, but you can also craft your workflows using C#. Dynamic activities from sources, this is a very powerful feature. Basically, you could have any source and dynamically emit activities. So for example, let's say you have an open API. Instead of manually creating activities to consume your API, you could dynamically generate those activities off of the specification. That works also for GraphQL, anything really that has a source and you want to somehow be able to invoke something in the form of activities, this will be a great way. And I don't think Orchard has this, but I'm not entirely sure, I couldn't find it. Dynamic expressions everywhere, so any input, every input of any activity, you can change from the literal UI input to a dynamic expression using any of the installed syntaxes. So that includes JavaScript, C#, Liquid, Python, or even your own if you want to, for example, use PHP or Ruby. That would all work. Another key difference is that workflows in Elsa are versioned, which is not the case in Orchard. And this adds nice benefits. For example, you can go back in time, you can publish a workflow and work on a new draft and publish it later whenever you're ready. And another important feature is the ability for the engine to execute activities not only sequentially and synchronously, but also asynchronously, which gives you true concurrency. So you can have multiple activities running in the background, and the engine orchestrates and synchronizes the work. So everything considered, there's a lot of similarities. Elsa brings more features to the table, but at the end, they're workflow engines in .NET, and so in that respect, they are very similar. So now, what does it bring us when we combine the two? When we embed Elsa into Orchard, we get direct access to the entire Orchard ecosystem, including its APIs, other modules. So you can implement scenarios where you want to invoke an action based on some event. For example, a content item has been created. You can interact with the GraphQL API or the SQL queries. Anything that you have in the Orchard framework, you can interact with, which of course is very powerful, even though even the existing workflows module is already super powerful, and Elsa will then take that to the next level. Okay, so let's look at a demo. I've split it in two sections. I'm going to show you some of the basic Elsa functionalities, and then we'll see how we can use Elsa together with Orchard and how that integrates. So here I have set up a new instance. It's based on the blog recipe, which is convenient because it comes with existing content types. Already enabled a new module that integrates Elsa into Orchard. So there's a new module that brings in Elsa packages for convenience. And just to give you a quick look, if we go to features, we filter on the Elsa keyword, we see a bunch of them, but the core module that we are interested in is Elsa workflows, and this enables core Elsa functionality, and the rest is our add-ons. So, for example, we have the contents module, which is a separate module that binds Elsa with content-specific APIs. And so that gives you activities like content deleted, published, but also actions to create and update content. So let's have a look. We have a new menu here, it's Elsa workflows. And so we have workflow definitions and workflow instances. And the first one will be a nice hello world. And this designer is directly embedded from Elsa Studio, which is implemented using Blazor. We are here hosting Blazor WebAssembly. And we'll talk a little bit more about that later. So here we have the design service, we have the activity picker, and some workflow properties on the right hand side. And here at the bottom we have the activity property panel. And so let's add a activity called write line. So this is going to write a line to the console. So yeah, let's publish, which shows us that we have, I just made a small change, so we already created a new draft, but the published version is version 1. So we have version history here. And so we can see the version 1 is published. We are currently working on a draft. So that's the versioning. Which, by the way, workflows, this integration implements workflows as content items. So it's also directly leveraging Orchard Core's versioning system. All right, so here we have a play button, so we can execute the workflow directly. And here we see a little journal which logs the individual steps of an activity. And then here, when we select this one, we see that it's used the hello world text, and of course, if we switch to the back end, to the console, we should see the console line written here. All right. So let's go back to the editor. A recently new feature is a test tab here, which is very convenient if you have a large workflow and you need to try out certain configurations. It could be inconvenient and cumbersome to have to execute all the steps in the workflow. But with this feature, you can test individual activities and see how they behave. So here, when I press start, we see that this worked. And so now let's make it a little bit more interesting. So we also have a thing called variables, which are just like in a C# program. You can define fields or properties on a class for local variables in a function. These variables are scoped to the entire workflow. And we're going to call this name. Variables are strongly typed, so we can give them a type and a default value. All right, so now we have a variable called name, and we're going to use that. So here, notice this little, I guguess, hamburger menu. Here we have an extensible set of syntaxes, as it's called. And we're going to choose C#. And then we're going to use that variable. Like that. All right, so let's see if that still works. We press the start button here in the test section. And that worked as well. And another nice feature of the test feature is the ability to provide test values while you're testing. So we can click this little flask, and then we can say Prague. And now, of course, when we press start, we see a different text. All right, so let's make this simple example a little bit more interesting. We can add triggers. For example, we can add an HTTP endpoint, which effectively makes this workflow accessible through HTTP. So here we have the HTTP endpoint. We'll configure its path. We'll enable the get HTTP method. And then we'll connect that to this activity here. And also we'll write a response to the HTTP response object. Like that. And then we're going to just copy and paste this input into the content here, also using C#. And then we'll publish this, and we'll take the full URL here using this copy button. And then we invoke the workflow like that. All right, so this all is just comes out of the box with Elsa. So now let's take a look at integration with the Orchard system. So we go back to the workflows overview, and let's create a HTTP requests demo workflow. So here what I want to show is I want to show another HTTP activity, but this one will fetch some JSON from some API, and then we're going to turn that into content items. So let's use the HTTP request, which is a thin wrapper around an HTTP client. And we're going to make a call to, I forgot the URL, but I have it here. The fake store API. And we'll run it using the test feature, so we can look at the response to see what kind of shape the response looks like. So here we have parsed content. And so we get an array of product objects. So we have objects containing a title, price, description, etc. All right. And so what we're going to do, we're going to loop over each product item, and then we're going to create a product content item. And to that end, I will create a variable to capture that array of products. So we're going to have a products variable. And it's going to be an array. And so activities, what they have inputs, as we've seen here, but they also have outputs, as we can see here. And this one has different outputs, and we are going to be interested in the parsed content output, which we could reference through scripting, like JavaScript, or we can also bind it directly to a variable here, which is more convenient. And so next, let's add the for each activity. And for each is an example of a composite activity because it has a property called body. And what it's going to do is going to iterate over the items in the associated list and then schedule the body activity for each item. So let's bind the products variable to its items input. This UI should be a variable picker, but that's not yet implemented, so we have to explicitly select the variable syntax, and then we can pick the variable. And obviously we could also have used JavaScript or any of the others. So we're going to connect it to 100 outcome, which by the way is directly inherited from the Orchard workflows module, which also has this notion of outcomes, which is quite convenient because it saves us having to add a decision activity to the workflow. All right, so here we have for each bound to the products variable. And now here we are going to use a Orchard activity, which is the create content activity here. And so here we get the option to select the content type we want to create. So that's going to be the product content type, which I created in preparation. And here we're going to input the property. So that's a JSON shape or JSON representation of the product, which looks like this. So we have a display text, the product part and its fields, some markdown part and some title part. And this get current value. This is like a magic variable created in the scope within the for each activity. So I'm taking advantage of that using JavaScript. So that's basically, the model is an individual item in the products list. So let's copy this in here. Switching to JavaScript. All right, and one thing that I want to do as well, I also want to take advantage of the taxonomies that we have. So when I enabled or executed the blog recipe, it also created a categories taxonomy. And now this products API also returns products associated to a category. So we're going to take advantage of that. And what we'll use is another activity called resolve term. And what this will do, it will see if a given alias or a title exists as a taxonomy term. And if it does, then it will resolve into that term content item, or it will create it on the fly. So here we get to specify the alias or the handle of taxonomy, which could be improved by just showing a drop-down list of taxonomies. But for now, we'll do it like this. So that's the taxonomy handle, and then here we'll switch to JavaScript, and we'll say return. Oh, actually, that's not even necessary. We can just say variables. No, sorry, it should be get current item. And the field is category on the product object, so this should be okay. Okay, so now we have we resolved the term. It will produce the resolved content, the term as a content item object, which we can use here in the create content activity a little bit below. So here, instead of this hard-coded term, we're going to say get result from term 1. These JavaScript functions are generated based on the available activities in the workflow definition and their available outputs. So these are dynamic. Dot content item ID, because what it resolves into is a content item, and that has a content item ID, which we provide here as the term ID. Okay, so let's save this and let's see how this works. Okay, I think I may have made a mistake. So let's go to the instances. We see the workflow instance has faulted. So let's see what's going on. This one has executed 0 times, which means it has started but not completed. And so here, there's an issue. The status is faulted. And it says, failed to evaluate activity input alias. Okay. So I'm gonna see if I see the issue immediately. If not, I'm just gonna import a prepared workflow. Oh, I see. So it's not get current item, it should be get current value. That was my bad. Okay. Get current value, that's correct. Okay, let's try this again. Okay, that's better. So we have for each, we drill into the body, and we see that both activities have executed 20 times because there were 20 products from the API. And so we cannot actually inspect each individual execution. So if we, for example, will select resolve term, we go to executions. We see a list of executions paginated. When we click on one and scroll all the way down, then we see the the state of that execution. So we see that this one resulted into a term content item with the title electronics. So this was just created on the fly, by the way. And so the same goes for create content. And because this seems to be successful, we should be seeing a lot of products here in the content overview, which we do. So we see the title, category, price, etc. All right, one more example is handling content events. So I will create another workflow, and we'll call this auto-correct blog posts. So here what I want to do is I want to handle events whenever a blog post is created or updated, and then automatically fix any typos, punctuation errors, that kind of thing. So for that we will just add the content created event activity here, and we'll configure it to listen for blog post creations only. This one too produces an output of type content item, so we can well, we receive the content item as an argument, so to speak, whenever this fires. So let's capture that. We'll call it content item of type content item. Okay, and then we are going to use a feature that comes from Elsa extensions, which is a separate repo, but it adds more functionality to Elsa. And this one is powered by the Elsa agents package. And this is actually another good example of the dynamic activity generation, because actually I should show you this, it's pretty cool. Yeah, so here we are looking at the source code of this demo application, which is a Orchard. It's an ASP.NET Core project with Orchard and Elsa packages. And here in app settings, we have a section called agents. And these are basically pre-configured GPT prompts. And they consist of information like a system prompt, description, and some inputs and outputs that is more specific to Elsa, and we'll see that in a second. And the ability to give it tools, like in this example, a web search tool. And these are just C# classes that give your GPT tools to access other systems and logic. And of course, the execution settings to configure things like temperature, max tokens, that kind of thing. One of these agents we're going to use here, which is the proofreader. So as you can see, these activities, they were generated off that source, from that source. Okay, and here what we want to do, we want it to just look at the contents of the created content item and fix any errors. So let's give it a input. So we're going to have to serialize the content item to JSON. Like that. And then we're going to capture its output in another variable. And that's going to be called corrections. Okay, and then of course it's we will have the corrections, and then we're going to update the created content item automatically. And for that we'll use the update content item activity here. So it needs to know the content item ID, so we'll use an expression. We'll call it get variables.content item ID. And the properties will be available from the corrections object. The agent was configured to produce a model that includes the corrections, corrections dot result. All right, so I'm going to publish this, and we'll create a new blog post. And we're going to create a blog post with a few errors in it. So we can immediately notice a few typos in the title. And we'll have a subtitle. Like that. And we'll save this as a draft. So this is taking a few time. Well, this was a little bit faster than I expected. That either means the AI was very fast this time, or I made a mistake. But let's have a look. Okay, I made a mistake. So proofreader says an error. Input is null. Okay, so I made a. So this stopped early. Let's see. In content is null, so I made a mistake here. Okay, I think I forgot to bind the output to the content item variable. So this one is bound. Let's try this again. But of course, we already created a content item. Either I have to create a new one, or we can add another trigger for content updated. Let's do that. Content updated. Which is good because now we have an example of a workflow with multiple triggers. Like that. It doesn't become a trigger automatically. We have to tell it that it can start this workflow. Like that. And of course, we need to bind the content item variable to its output. And now when we publish this, so trigger should have a payload, of course. It should specify that it's at least one filter. At least that's how this activity is implemented. I think technically we should allow it to default to any content type. But yeah, for now we need to check this. Let's try that again. And now I'm just gonna update this faulty blog post. And so this takes a little bit longer because the entire workflow executes synchronously. So as Orchard is published in the workflow, it invokes all sorts of handlers, including the handler installed by Elsa, to execute the workflow. And we're going to fix that. So while this goes, we can inspect the console output, just to make sure there are no network errors or anything. And by the way, this is implemented using semantic kernel, and it's configured to connect to an OpenAI API. Okay. So we can already see that the typos have disappeared. They have been fixed. Everything looks good. And so that also should mean that the workflow instance executed successfully. And we can indeed see that it was triggered through this trigger, went through the proofreader, which produced the following output. So we see the result, which is the content item with the fixes. And we see a corrections count, so I found 5 issues, and then a div, which maybe instead of automatically applying the corrections, maybe you want some UI where you review it manually and then apply the diffs explicitly using a button. That could be used for that. And then we updated the content item. But earlier I mentioned activities can run, well, synchronously, but they can also run asynchronously. So in this case, that would be very good because we don't want publishing or saving content items to be this slow. So let's change that. So the bottleneck is the proofreader. So let's change that to run asynchronously. Okay, and then we'll publish this. And now let's see what happens. I'm going to just save this again. And this time it was very fast. If we go to the instances, we see that the workflow instance is suspended currently, which means as much as it's working, but it's waiting for some stimulus or stimuli to resume the workflow. In this case, the engine scheduled a background task to execute the agent, and then it's created a bookmark, and that would then be resumed automatically by that background task. And so I just refreshed, and we see it's now finished. All right, so let's see. I didn't clock the time, so I have no idea how far along we are.
We got a couple more minutes.
A couple more minutes?
Yeah.
Okay. How many couples?
3 plus the Q&A, so...
Okay. Let me switch to the custom activity development. Just to give you an idea, it's very simple, but it's interesting to see. Here we are back in the source code of the demo application. So what does it take to create a custom activity? Nothing much. Here's an example of a sum activity. It's a class. Ultimately, you need to implement iActivity, and then there are there are a few base classes that make that easy. One of those base classes is the code activity, which allows you to optionally produce a result. And to provide inputs, you just declare them as public properties, optionally wrapped with an input type, which gives you the ability to the user to switch between syntaxes. If you don't use input, then the user will only see a literal UI, which means as much as like a basic text box, which is sufficient for some scenarios. But for when using input, you have those other options. So here, this activity is a demonstration of accepting 2 inputs and then producing the sum of those inputs as its output. And you have, of course, the ability to provide some metadata, like a technical namespace, a category, which is then used in the designer to put it in the right category, and obviously a description. Yeah, I could show more, but this is what I really wanted to show. I'll take questions.
So, stay on this screen. I'm a little bit curious why you chose to use a context to set the result, like a context object that gets passed in, whereas you have input properties. Could you have made the API so that this is more homogeneous?
So
see what I mean?
The same is actually for the, I'm not sure I understand, but let me explain what's happening here. So we have these input properties. To get the value, you have to say property.get, and then you pass in the context. And then you also need to use the context to set the result. Effectively, what we're seeing here is this class, if it's instantiated, it's an instance of the workflow blueprint, and the activity instance actually executing is represented by the context here, which I took from Windows Workflow Foundation as a guiding principle, but I'm pretty sure it could have been done in a way where the activity instance would represent the actual activity instance and not the instantiation of the blueprint.
Do you already have or plan to have activities that can interrupt a workflow? I mean, something that would require a user interaction. So you would have a workflow describing a business process that requires at a certain step a user having to upload the document or validate something.
Yeah, so that's a pretty common request. We don't have anything yet. But at some point it will be there. If there's some request and a use case, then it will be implemented. It is there on the roadmap, but not yet implemented.
Thank you.
I would have two questions. The first one about this being able to write C# codes. How safe is that? I mean, can you just write any C# code there, or is it sandboxed in a way?
Yeah, it's sandbox. You need to explicitly expose the functions, methods, and types that can be executed. So it's using Roslyn, and you have to configure what it can do. So it should be safe.
Oh, great, thank you. And the second question, especially that you also denote using an agent. Currently, or in the near future, how do you see how much of a workflow could an agent execute? So how much of the tasks you can actually substitute with a prompt, pretty much?
Yeah, it's a good question, and that's something that we're continuously learning to find a balance. How much do we leave to the agent? The more you leave to an agent, depending on your instructions, it's very deterministic to a certain point or less. And then on the other hand, you want deterministic processes. So that's where a workflow engine, a visual process that's created by a human or an agent or an AI is preferable because it gives you control over exactly which steps get executed. So it's to me it's a little bit of an art still to determine what you leave to the agent and what you do explicitly in the workflow as a step.
Thank you.
First of all, thank you for the presentation. I think it's absolutely game changer, these workflows. I would like to ask if you plan to implement an AI that would design the workflows for users.
Yeah. So we have. I started a little experiment where we have basically. I'll show you what I'm thinking is. If you look at Writer, where you have this AI agent, and then you have these modes. Actually, maybe GitHub Copilot is a better example. You have these three modes, and I want to build that pretty much as is into the Elsa Studio or in the UI, where you have a new natural language input, and then you can just use it to ask questions about your workflows, workflow instances, or anything else that's in the system. But then also give it instructions to create your workflow or modify your workflow. This is an ongoing process.
Yeah. Okay, thank you.
Thank you. Great presentation. So my first question is, how does it scale? So I'm talking about the engine.
The workflow engine
Yes.
scales horizontally, so it could scale infinitely depending on your hardware. Usually the bottleneck is the database that can become very slow, no matter how many nodes you have in your cluster, but it's built for scale.
Okay, so once the nodes expand horizontally, so it scales for the increased number of elements. My second question, I thought that it was smart enough not to trigger after the workflow updated the content trigger, because you see it had a content trigger.
Mm-hmm.
So how do you avoid an infinite loop in this situation?
Good question. So actually, I don't know why it didn't enter that loop, because it should have, I think. But the way to prevent that is like this. So I'll show you. So here, the way it should have prevented it is by the activation strategy, and it should have been set to correlated singleton. And what that means is that only one instance is allowed of this work definition for a given correlation ID. So I should have set this here, and then I should have correlated this workflow instance to the content item ID that was published or created or updated. But it's good observation. I need to look into why it didn't enter this infinite loop.
And one last quick question. So the custom activity has the execute method, which is not which is synchronous.
Yeah.
So does it have the asynchronous override?
So the way this works is that out of the box, all of the activities, they just execute synchronously because the workflow engine just works through an in-memory queue. But if it's set to run asynchronously, this piece of metadata the engine sees, and then it, instead of just invoking the execute method of the activity, it's going to schedule a background job and then suspend the workflow instance. Unless there's more work on the queue, it's going to finish the queue, but then in the meantime, in the background, the activity will execute. Once that's done, it will resume the workflow instance. And this works for multiple activities running in the background. So you could fork out to multiple branches and have work execute in parallel.
What modules of Orchard does these depend on?
So let's have a look. So the core module depends on content, liquid, OpenID, which is important because the designer, which is built in Blazor, it needs to make API calls to the backend, but the backend also needs to set a claim because the Elsa backend API, which is also hosted in his workflow instance, expects the permissions claim to be there, which is hard-coded currently to be an asterisk, which means all permissions. But it could integrate perfectly into the permission system of Orchard.
Thank you.
Hi. Does this roll out multi-tenancy as well? So if you've got Orchard code with multiple tenants,
Yeah.
you centrally manage those workflows?
Yeah, exactly. We could just create a new tenant here, and then it will have its own set of workflow definitions. The executions will all happen within the dependency context or the shell of that tenant. Yeah, and Elsa itself is also multi-tenant, even at the record level. So there's a tenant ID discriminator, so it takes it one step further, but that's more suitable, I think, for other ASP.NET applications outside of Orchard.
Thank you.
Other question? Thank you very much for your presentation.